we won't be communicating with them, but we will be receiving their communications and data during that time frame.
Do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over.
Tell me more.
Then we'll take it to a higher fidelity environment, like the Orion mock-up.
You're going to do the plan how you expect it to be,
volume is smaller, the window placement,
once we finalize that plan, we'll
give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense. And we'll reiterate on it over and over. We'll take it, then we'll take it to a higher fidelity environment, like the Orion mock-up during mission simulations.
And we'll do the same thing.
Highest fidelity that we can do before we
window
send it to space. So this is the first time we've had to do this because we're a brand new console
edition of this environment.
It just sparks so many neurons. Like, how are we going to do this? Reiterate on that. We'll take it, integrate this, give it so many different ways. So excited to have it during mission simulations. But there's the highest fidelity that we can do before we
and I think it was really well thought out too.
This is the first time we've had to do this because we're a brand new console.
To do each task,
and so it just sparks so many neurons. Like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have
something that one
kicked off this process, but there's so much more
than something another person notices. And I think it was really well thought out. We also know that each crew member gets an opportunity to do each task, but you're getting different perspectives and different insights from each crew member. Maybe even a vantage point scientifically interesting.
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques.
So we really tried to make the plan to optimize those.
There's pros and cons for all those things for this mission, so we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things.
Yeah,
this zoomed out. Observations are so fundamental in the scientific toolkit, particularly observations from different perspectives.
Y este es el modelo de 30 litros. Este modelo es el más popular en el mercado actualmente y podemos ver algunos detalles de este tronco.
They're different,
Estas
the different things
son
they're able
las
to observe.
hélices, el
So yeah,
motor
let me talk a little bit about scale,
eléctrico,
because I think
las
observations at
boquillas
different scales,
centrífugas,
you can gain a lot of different information.
y este es
So
el
like, for
tanque
example,
para
if you're an
guardar
astronaut
el
on the
agua.
surface looking at a rock, and you describe at this
La
micro
bacteria,
scale. So in training, we
y
kind
de
of talk
abajo
about
es la
observations from
bomba de agua.
micro to macro,
Este modelo
or from
cuenta con
outcrop to orbit.
perfecto
So looking
efecto
at
de
a rock at
pulverización
this scale, you can describe its
que
components, you can describe what it's made of and its
realiza
colors and its minerals.
un efecto
Like, okay, and
trabajo.
this rock came from this boulder, and it's
This
a
part
rock
of this
at
boulder,
this scale.
and
These
you
are
can
the
describe its
different components you can describe what it's made of and its colors and its
gives me
minerals.
context to the
And you're like,
sample.
okay, and this rock
And then you
came
zoom out a
from
little
this
bit more,
boulder.
and you're like, okay,
and
well,
it's
I can
this
see
part
that
of
this
this boulder
boulder
came
and these
from,
are the different
it
things
rolled
that I'm
from this
observing
mountain
around,
ridge,
or this
gives
this high rich feature.
And then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high rich feature. And then because I can see the trail that it came from, okay, now let me describe this ridge and, different parts in it and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information. And so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar on Earth, we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. Yeah. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set, Yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience in that we don't normally see this activity, and so being able to have crew observe the solar corona and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like why are they observing this, like what is going on. So I think that's just a really cool part of exploration and science and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out, and we have pictures that they can just draw right on as like this particular thing is different than what we've seen. So I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on Console.
Thank you, and you've been doing a great job, and so excited to see where we go from here.
Thank you so much.
Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We're live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This a live view from the Orion spacecraft with our Artemis II crew inside. That's Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis II. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The crew is in a little break during our flyby coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis II crew, working in the middle of one of their breaks, or really their only break today during this lunar flyby period. Coming up next will be that solar eclipse. Throughout the Artemis II mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis II crew members named their Orion spacecraft Integrity during a news conference September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency. We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis II. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis. Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Houston integrity in the blind. High priority PAO activities on Reed's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
This is Artemis Mission Control. You heard Reed Wiseman, commander of the Artemis II mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis. The view on your screen right now is an animation. This is called Arrow, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/trackartemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes. This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis II mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now, we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images of the corona during the eclipse. There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it. The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts. You're getting a live look from Orion as the crew observes a solar eclipse from the moon. And this solar eclipse is only visible to the crew on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses, just like we do from Earth, to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby. What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reed is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
Again, you're looking at a live view from the Orion spacecraft on the Artemis II mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis Mission Control Room in Houston, Texas, and what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft. You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely. It has been an absolute honor to join you here today for the lunar flyby of Artemis II, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
game is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine, and it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Director Diane Daly, and she is currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan. The Artemis II crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors, science.
So we are in a forward link loss of signal. We do expect to regain signal in about 3 minutes. And at that point, then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond. So they are continuing to provide some science observations during this eclipse period. They've made some comments about Earthshine, which is the sunlight reflected from Earth when they come around towards the moon's near side late in this flyby window. And there on your screen, you can see all of the Artemis II crew members. CSA astronaut Jeremy Hansen just floated out of view behind the camera, but you can still see NASA astronaut Reed Wiseman, NASA astronaut Christina Cook, and NASA astronaut Victor Glover as they prepare for an upcoming Public Affairs Downlink event, which is scheduled to take place in just a couple minutes from now. And there, floating back onto the screen, is CSA or Canadian Space Agency astronaut Jeremy Hansen. He is making himself comfy on some of the OX or Orion Crew Survival System suits that have been stowed for the outbound and now return journey. Shortly after the completion of these couple of public affairs downlink events, the crew will begin winding down for their day, and they will have the opportunity to eat dinner. Some of the items on their menu today for dinner include chicken with corn and black beans, sweet and sour pork, rice pilaf, spicy green beans, citrus fruit salad, and maple cream cookies.
Cubículo de média tensão com 12 colunas, modelo AirSafe, padrão e qualidade Indus Power. Fabricado.
And now we will go ahead and stand by for the public affairs event beginning in just about a minute.
Integrity Houston, no action for the DU-1. Caution, we're taking a look. Integrity, this is Houston. Are you ready for the event? For the event.
Hello, Houston. Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear, sir. How us?
I've got you loud and clear. Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reed, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reed Wiseman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen. And I also want to thank the entire amazing team at NASA, headed by Jared, who's a very special guy, by the way, and you all made this day possible, and you've really inspired the entire world. Really, everybody's watching. They find it incredible. I just watched you go to the back of the moon, and people haven't been there in a long time, we can say, but it's going to be more and more prevalent because we're going to be doing a lot of traveling, and then you're going to ultimately do the whole big trip to Mars, and that's going to be very exciting. So you look at, we had no astronaut has been to the moon since the days of Apollo program. The Apollo program was also very special, but that was 50 years ago. And at long last, America is back, and America is back in many ways stronger than ever before. We're the hottest country anywhere in the world. The Artemis crew flew in the most powerful rocket NASA has ever made, ever launched, traveled over 250,000 miles, broke the distance record set by the legendary Apollo 13. And America is a frontier nation, and the 4 brave astronauts of Artemis II are a modern-day, you really are modern-day pioneers, all of you. And one of them happens to be a neighbor. You know who that is, right? You have a special person over there, a neighbor, and we like our neighbor. Your mission paves the way for America's return to the lunar surface very soon. We're going all out. We're doing everything we can, and it's headed up by Jared. We'll plant our flag once again, and this time we won't just leave footprints. We'll establish a permanent presence on the moon, and we'll push on to Mars. That'll be very exciting. I'm waiting for that so much. I'd love to be here, but maybe we won't quite make it in terms of timing, but we will be up in the moon, and that's going to happen soon. So America will be second to none in space and everything else that we're doing, and we will continue to lead the whole thing into the stars, this incredible journey into the stars. So I just wanted, it's an honor to speak to you, and I wanted to congratulate each and every one of you. And tell me, what is the most unforgettable part of this really historic day? The whole world is watching and listening. Please tell me.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Jared Isaacman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of it. I have to tell you, as we came around the near side of the moon, seeing all the sights that we've seen from Earth for all of our lives, but we're seeing them from a different perspective, and then we started to get a glimpse of the and we saw sites, Oriental sites that no human has ever seen before, not even in Apollo, and that was amazing for us. And then the surprise of the moon and the entire dark moon about that big right out the window that we were watching. We could see the corona of the sun, and then we could see the planet train line up, and at Mars, and all of us commented how excited we are to watch this nation and this planet become a 2-planet species.
That is fantastic. You know, I had a decision to make in my first term, and the decision is, what are we going to do at NASA? Are we going to have it be revived, or are we going to close it down? And I had very little hesitation, and it's really great to have somebody like Jared involved, because he really makes it much easier for me. But it was not even a question in my own mind. We've spent what we had to do, and then of course we have Space Force, and Space Force is very much related to what you're doing, and that was my baby. That was a very important one, and it'll turn out to be truly one of the most important, I believe, decisions I've ever made. So we're very proud of Space Force, and we're very proud of all of you. Does anybody else have anything to say? A lot of people listening.
Mr. President, to be here with you speaking about our incredible day today. I think one of the biggest highlights was coming back from the far side of the moon and having the first glimpses of planet Earth again after being out of communication for about 45 minutes. It really just reminds you what a special place we have and how important it is for our nation to lead and not follow in exploring deep space.
I'd like to ask, what was your feeling when you had no communication, zero communication? All of a sudden it was cut off by, obviously, your very special location. What was your feeling when you had no communication? A little bit different, perhaps.
Yes, Mr. President, it was cold. I said a little prayer, but then I had to keep rolling. I was actually recording scientific observations of the far side of the moon. You know, that is actually the time when we were the farthest. and the closest to the moon. And so we were really able to make some of our most detailed observations of the far side of the moon up close. And so we were busy up here working really hard, and I must say it was actually quite nice.
Did you see a difference, a big difference between the far side of the moon and the near side of the moon? Was there a difference in feel or difference in look? What did you see?
Well, Mr. President, we certainly did, and our science team really set us up well to understand what they thought we might see. And the gravitational pull of the Earth has had a profound effect on the near side of the moon, changing all those dark mares, those dark patches of the moon you see from Earth. It's very different on the far side. While you see some small patches of those mare in deep craters, it's very much absent on that side, so that's really neat. And while I have the microphone, sir, I just want to thank you on behalf of Canada. The space leadership you spoke of from America truly is extraordinary. I've said this many times before. A nation that leads like that and creates and sets big goals for humanity that brings other countries along with it is truly incredible. And I know that's a very intentional, not a necessary decision, intentional decision to lead by example and to allow other countries like Canada to share our gifts and help you achieve these mutually beneficial goals, like establishing a presence on the moon and eventually going to Mars. And Canadians are so proud to be a part of this program.
Well, I have to say I spoke to a very special person, Wayne Gretzky, who I think you know, the great one. And I spoke to your Prime Minister and many other friends I have in Canada. They are so proud of you. And you have a lot of courage. I'm not sure if they'd want to do that. I'm not even sure if the great one would want to do that, to be honest with you. But you have a lot of courage doing what you're doing, a lot of bravery and a lot of genius. But they're very, very proud of you.
Administrator Isaacman, just get a quick comm check, make sure you guys are still on the line and we didn't have a handover.
I am. Yes, I am.
And integrity, and back over to you, Mr. President.
Yeah, I think we might have gotten cut off. It is a long distance. It's a long ways. The reception's been great. There's a little bit of about a 9-second delay, but no, I just had a statement for, I don't know what you heard, but I was just saying they're very proud of your brilliant person from Canada on the ship. And Wayne Gretzky is a great friend of mine, and he's very proud of him. And the Prime Minister I spoke to, they're very, very honored that you have a courageous person from Canada. You have a lot of courageous people from Canada. So it was very nice. I'm not sure if you heard me say that, but it was very nice.
Yes, Mr. President, we heard that, and we do love our Jeremy Hansen. We love all our Canadian astronauts, Jenny Gibbons, Josh Kutrick. They're just great people, and they're such a welcome addition to our Corps.
Great. Well, I really look forward to, when we can, I look forward to seeing you in the Oval Office. I'll ask Jared to bring you over, and I'll ask for your autograph, because I don't really ask for autographs much, but you deserve that. You really are something. Everybody's talking about this. And I look forward to having you in the Oval Office at the White House, and we will celebrate your incredible achievements and triumphs. This is big. This is really big stuff. The whole world is talking about it. And if you have the time, I will certainly find the time. I've been pretty busy also as you know, but I will absolutely find the time, and we'll get together, and I'm going to be giving you a big salute on behalf of the American people and beyond that.
Thank you for that, Mr. President. And when you want us, we will be there. And thank you for your leadership. Thank you to Jared for his leadership. Really, thank you for taking the time out today to visit NASA. It's really special for us, but it's really special for the team on the ground. A whole team of people all around the world pulled this off. And we just want to say thank you to all of you for this. It is the thrill and honor of a lifetime to have been on this journey. Today was amazing, but this 3-year journey has been amazing, and it was made possible by the American people and the Canadian people. And we're so grateful to you all. Thank you very much.
Well, thank you very much. And Jared, congratulations. We'll see you soon. And I know that you have Mars very much in your mind, so we'll start thinking about that pretty soon, I think. And thank you. Congratulations to everybody. I'll see you at the Oval Office.
Thank you for your time, Mr. President. It's been an honor.
Thank you very much. Bye.
Bye.
Integrity. This is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio communications. Integrity Houston, great job on the event. Just a heads up, we are on track to start the next event on time at 4:15.
Okay, sounds great. We'll be ready.
This is Artemis Mission Control in Houston, Texas. We just had that public affairs event with President Donald Trump and the crew on board the Orion spacecraft. And coming up in about 10 minutes, there will be another public affairs event. That event taking place at a mission elapsed time of 5 days, 4 hours, and 15 minutes. Currently on your screen, you're seeing a look at the Artemis Real-Time Orbit website, which provides updates on the velocity as well as the distance of the Orion spacecraft from both Earth and the Moon. The Orion spacecraft and its crew, that crew including Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, are currently about 250,000 miles away from the Earth, and that distance is starting to become smaller as they are now on the return leg of their journey. And they are about 9,300 miles away from the Moon. They made their close approach to the Moon.
Integrity Houston with a question about fan speed.
Go ahead.
Hey, Reed, we were wondering if this adjusted fan speed is something that you would like to keep going forward, or if it was just a specific change request for the events this evening.
Certainly for PAO events, this is an ideal fan speed. If you're willing to give us this fan speed for routine habitability, I think we would take it and try it for a while.
Meu trabalho é fácil porque eu uso o ClickUp. É assim que eu acompanho todas as minhas tarefas. Eu começo despejando tudo o que preciso fazer em uma...
And Reed, we are Able to support keeping the fan speed in this config. Happy to keep it here to collect data.
Okay, you got 4 happy astronauts up here. We'll take it. Obviously, when we go to exercise, we'll need to bump it up, but I think for quiescent living, this will be great.
We copy, and we love seeing those smiles.
Houston, integrity for docking camera.
Go ahead.
Just want to make sure we have the config you're expecting. I have the dual camera bracket is installed, the window shade is closed, and the docking camera is stowed in its Alpha 3 storage area.
That's a good config.
Thank you.
And while I've got you, we are 3 minutes out from an on-time start of the next event.
This is Artemis Mission Control in Houston, Texas. You can see a live look of the Artemis II crew inside the Orion spacecraft cabin as they prepare for another public affairs downlink event. There on your screen is CSA astronaut Jeremy Hansen along with NASA astronaut Reed Wiseman and NASA astronaut Victor Glover popping up. Earlier today, the crew completed their lunar flyby observation period, during which the Orion spacecraft and its crew passed approximately 4,000 to 6,000 miles from the moon and provided the astronauts with a full disk view of the lunar surface. And from that higher vantage point, the astronauts were able to observe both poles and large-scale geological features in a single view. Towards the tail end of that observation period, they also were able to see an eclipse. And that eclipse period lasted about an hour and was when the sun was hidden from view behind the opposite side of the moon from the perspective of Orion. Since then, the crew has been working to clean up some of their observations and transfer some of the data and imagery down to the ground to begin processing, and the science team will take a look at that imagery as it comes down ahead of a post-lunar flyby conference tomorrow with the crew following their sleep period. Now we are standing by for a second public affairs event taking place in about a minute.
Integrity, this is Houston. Are you ready for the event?
Houston, Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear up here.
I've got you loud and clear, and let's see if we can top that last PO.